All right, let's go ahead and graph these cotangent curves, and then we'll head into the remaining two functions. All right, so again, there's no amplitude for cotangent either. So let's get the period. So pi divided by a fourth should be 4 pi. So cotangent, I like to graph this one better than tangent because I don't have to use a weird little splitting thing. The thing about cotangent is it's got a vertical asymptote anchored at 0. So its starting place is just fine right at 0. So that means the distance from start to finish is just the period. So from asymptote to asymptote is the period. So 0 to 4 pi. And then right in the middle is your x-intercept. Just like that, right at 2 pi. Okay, moving on to part D. Period, we're going to take pi, divide it by the b, so just pi over 6. Nice and easy. Vertical asymptote at 0. And another vertical asymptote at pi over 6. But this time it's negative out in front, so the cotangent curve is upside down. Going just like that. And it's right in between 0 and pi over 6, and that would be pi over 12. So not too difficult to draw. All right, we have two more functions, cosecant and secant, so let's get their parent functions up there. All right, let's do cosecant first. So just like cotangent has a vertical asymptote at 0, and then vertical asymptotes at those whole number pi's. So pi, 2 pi, 3 pi, negative pi, negative 2 pi. And for cosecant, instead of being like an x to the third shape, it's actually an x squared shape. So it's a bunch of parabolas that alternate going up and then down and then up again. Just like that. And there's no amplitude for these because there's no max or min value, there's no top or bottom, but cosecant does stay out of like a band, this middle part of the curve, so it stays out of the region between 1 and negative 1. It'll hit those two values at the max and mins of the parabolas, but it doesn't go in between them. It just totally stays out. So it's kind of the flip of sine and cosine. Sine and cosine are trapped in there. Cosecant and secant are everywhere else. All right, so that's cosecant. Secant, it has the same overall idea, but it's kind of behaves more like tangent, in that it sort of straddles the y-axis just like that. But it's still those parabolic shapes to it. They're not perfect parabolas, they just kind of look like it. So just like that. So the asymptotes of secant are the same asymptotes of tangent. So pi over 2, 3 pi over 2, any odd number pi over 2. And then just like cosecant, it stays out of the region between negative 1 and 1. So they look rather complicated and scary, but they're not actually that bad. So let's look at the theorem, see how they're going to work. So for y equals a cosecant of bx and y equals a secant of bx, there is no amplitude. And the period goes back to what it was for sine and cosine. 2 pi over the absolute value of b. Now what I've seen some people like to do, just because they're taught to do it this way, for cosecant, what they do is they like to draw a sine curve at the same time that they're drawing a secant curve. So they draw the sine curve first, and then they kind of match the cosecant curve to fit. You can do that if you want to. You don't have to. I myself don't do it because I don't need to draw two curves. I can draw cosecant and secant directly, but if you don't like to do it that way, that's totally fine. You're not going to get it wrong by any means. You're just doing extra work. Okay, so if you want to have like a sine or cosine curve in there, that's totally okay. All right, let's stop the video here, and then we'll look at what happens when you start adjusting the period with these two curves.